Okay, here is how we do practice 3A. A couple things that we want to remember is that all atoms have protons in the nucleus. We're going to indicate how many protons there are in the nucleus with something called the atomic number. That's going to be this guy. Every element on the periodic table has an atomic number. We're also going to indicate with something called the atomic mass how many protons and neutrons there are. We're going to call this the atomic mass. Okay, you're asking what's the difference? The difference is that the atomic number is the number of protons. We're going to abbreviate protons P+. The atomic mass, on the other hand, is going to be the sum of the protons and the neutrons in the nucleus. All right? So let's take a look at our periodic table. So every element on this periodic table is going to have these two numbers. Lithium, for example, has an atomic number of 2. That tells us that lithium has 2 protons. Lithium also has an atomic mass of 6.941. Let's round that to 7. And because we know that lithium has 2 protons, that means that the remaining component must be neutrons, and in this case it must have 5. That adds up to 7. So that's how we're going to be looking at all of these individual ones. So when it's asking how many protons, how many neutrons, we're just going to look them up on the periodic table. And let's remember that we have 2 ways of doing this. We can indicate the number of protons in the nucleus down here. It's always the smaller number. The number of neutrons and protons up here at the top, it's always the larger number. And this setup is what we're going to call nuclear symbol notation. So when you see something that looks like this, it tells you pretty succinctly what's going on, how many protons, and if you know the number of protons, you know the atomic mass, you can always find the number of neutrons simply by subtracting. Or if we wanted to, we could write it like this, where we could say carbon 12. This is called hyphen notation. What's going on here is we know that if an atom of carbon, it always has 6 protons, so it's kind of redundant to say the number of protons, because if it doesn't have 6 protons, it's not carbon. And then we'll indicate with a hyphen the atomic mass here. So when they say hyphen notation, that's what they mean. Okay? All right, let's do it. We're looking at neon. How many protons are in an atom of each of the following? Let's take a look at neon. Okay, looking at neon, I'm looking at neon's atomic number here. That's the number of protons in the nucleus, and so all we have to do is look up the atomic number, and we know that neon has 10 protons in the nucleus. Let's look for silver. Okay, here's silver. We're looking at silver's atomic number, 47. That tells us that silver has 47 protons. Okay, you guys getting the hang of this? Alright, so don't need to be dragging these over because we can just scroll over to the periodic table. So we're looking for germanium. We see germanium right here. Germanium's got the symbol Ge. It's got an atomic number of 32. That means it's got 32 protons. We'll record that right here. Last one in number 1 is radium. We find radium right here. Radium has got 88 protons, so we'll record that here. And that's all you do. Let's take a look at number 2. What is the atomic mass of each of the following elements? Well, let's look up aluminum. Okay, atomic mass is the larger of the 2 numbers. Aluminum's got this atomic mass of 26.9815. Bunch of stuff. We're not really worried about that. We are going to round that up to the nearest whole number. Let's call that 27. And that's all you have to do. So we're going to look up, say, strontium. We see strontium right here. It's in group 2. Strontium's got an atomic mass of 87.62. Let's round that to the nearest whole number. We'll call that 88. We're looking up iodine. Iodine's a halogen. We can find that in this column. Iodine's got an atomic mass of 126.9. We're going to round that up to 127. Finally, europium. That's a big one. We're looking for that one somewhere in the bottom here. One of these big guys, and we see it right there. Europium's got an atomic mass of 159.964. Let's just round that to, what did I say it was? 1.964. Let's call that 152. 152. All right, that's how you do. Okay, number 3, it says using atomic mass and rounding to the nearest whole number. That makes things a lot easier when you round to the nearest whole number. Calculate the number of neutrons in an atom of each of the following elements. Well, let's see if we can find this stuff, nitrogen. Look what it says. It says nitrogen has got an atomic number of 7. That means nitrogen has got 7 protons. It's got an atomic mass of 14. If we know that that 14 is the atomic mass and it's the sum of neutrons and protons, then all we have to do is subtract the number of protons to get the number of neutrons. And of course, 14 minus 7 is 7. So we know that nitrogen has got to have, in this instance, 7 neutrons. All right, we see how that works. Let's take a look at potassium. We're going to find that in column 1. It's right here. Potassium's got 19 protons. It's got an atomic mass of 39. So what we're going to do is we're going to take that number of that atomic mass, 39. We've got 19 protons. How many neutrons do we have left? 20. Okay. Here's arsenic. Arsenic's way over on the other side of the periodic table. We see it right here, arsenic. Arsenic's got an atomic number of 33. That means it's got 33 protons, and it's got an atomic mass of 75. So we're simply going to take the number of protons and subtract take the atomic mass and subtract the number of protons. So if we have an atomic mass of 75 and we have 33 protons, right? We said atomic mass of arsenic, we said was 75. And we know that we have 33 protons. We have 42 neutrons. Last one is xenon, a noble gas. Right over here. It's pretty big. It's got 54 protons and an atomic mass of 131. So if we got, I don't need to run this out for you. You can do this for yourself. 131 is the atomic mass minus 54. 77 neutrons. Okay, getting close to the end. Here's number 4. This one is called hyphen notation, and this is pretty helpful because it gives us the identity, and we can look that up for the number of protons. And it gives us the atomic mass, and all we have to do is subtract the protons from the atomic mass to get the number of neutrons. And so we know that carbon has 6 protons. It's right there. That's the one that we've been doing all this time, right there. Carbon's got an atomic number of 6. That means 6 protons. So if all we have to do is subtract from the atomic mass the number of protons to get neutrons, 8. Okay? Here we are. We're looking at uranium-235. Uranium's a big radioactive element. It's right here. This is an isotope of uranium, meaning most of the time uranium has an atomic mass of 238, but this one doesn't. This has an atomic mass of 235. Isotopes are simply elements with differing numbers of neutrons, but their number of protons is the same. So every element, every atom of uranium is going to have 92 protons. So if we're trying to find the number of neutrons from uranium-235, and we know we have 92 protons, all we have to do is subtract the number of protons from the atomic mass, which we said was 92, and we get 143. All we're doing, ladies and gentlemen, here is ytterbium-180. Ytterbium is a big element. It's radioactive. It's here in the bottom. Ytterbium, we see it right here. And it's got 70 protons. This particular example of ytterbium has got an atomic mass of 180. So what we're going to do, since we know it has 70 protons, we can record those here. 70 protons. If we have an atomic mass of 180, all we do is subtract the number of protons and we get 110 neutrons. Plutonium 244, big radioactive element. Normally plutonium right here, well, actually, there's an atomic mass of 244. It's got 94 protons, so all we're going to do is subtract the 94 protons from the atomic mass, which we know is 244. And we get number of neutrons is 150. 244 minus 94. Okay, we're getting close to the end. Here we go. This one's pretty straightforward. In fact, this is nice because it tells us the atomic mass and the atomic number. This is called nuclear symbol notation. So we don't have to look it up because it's telling us. All right, we have iron with an atomic mass of 57 and atomic number of 26. So we know we've got 26 protons. We're simply going to subtract from the atomic mass the number of protons, 26, and we get 31. Easy peasy. Lead with an atomic number of 82 and an atomic mass of 208. How many protons? Right there in the atomic number 82. We're going to take the number of protons and subtract them from the atomic mass, and we get a number of neutrons that is 126. Here is calcium with an atomic number of 37 and an atomic mass of 86. Well, the atomic number is 37, so that's our protons. We're going to take the atomic mass and subtract the protons, and we get 49. Finally, uranium-235. Looks kind of familiar. We did that right up there. We have 92 protons, so we're going to subtract that protons from the atomic mass, and we get 143. Okay, these last four are dealing with what we call ions. Ions are atoms with charge. How do you get charge? You can either lose or gain electrons. Electrons are negatively charged, protons are positively charged. And so if you have an atom with a charge of +1, it has one more proton than electrons, meaning it has lost an electron. All we have to do to determine the charge is find the number of protons in the nucleus and then determine how many electrons by the charge. So let's take a look at barium here. Let's get barium's atomic number. Okay, we're looking at barium's atomic number, and it says here it's got an atomic number of 56. Easy, right? Well, this says it's got a charge of 2+. That means it has 2 extra protons, and since you can't really change the number of protons, it means to get a charge of 2+, there are 2 fewer electrons, meaning we have to have lost 2. So if there originally were 56 electrons to make the atom neutral, and we now have a charge of +2, we have lost 2 electrons, and we are now at 54. All right, we're getting the hang of this. Nitrogen's a pretty familiar element. We know that nitrogen's got an atomic number of 7. This particular sample has a charge of -3. That means there are 3 extra negative charges, or 3 extra electrons. If there were originally 7 to match the number of protons, and now there are 3 extra, it must have 10. Cobalt, pretty easy. Cobalt's atomic number, let's find it. Okay, cobalt we know has an atomic number of 27. That means there are 27 protons, and this particular example has a charge of 3+. That means there are 3 more protons than electrons. You can't really get rid of protons. That means it has to have lost 3 electrons, and so we have 24. The last one is bromine. Here we're looking at bromine, and it tells us that its atomic number is 35. That means it must have 35 protons. This particular example has a charge of -1. That means it has 1 extra electron. And so, in this case, if it originally had 35 protons and 35 electrons, now it has an extra electron. That means we're up to 36. That's all you do.